So this is half past paper week 7. We've got all the odd numbers. As always, all the list of topics is on the front cover, as well as the Sparks codes. If you do use Sparks Maths, you can go and look up more questions using those codes. We've got 39 marks out of 80 on this one, so 41 next week, and this is a non-calculator paper. Question number 1 is to write 180 minutes in hours. So we know that 60 minutes is 1 hour. So how many 60s fit into 180? Or if you're not sure, you can just count up. 60 is 1 hour, 120 minutes, that's 2 hours, and another one, 180, that is 3 hours. So 3 goes there. Question number 3, work out 10 times 3 add 5. And we are using BIDMAS here, so brackets, indices, divide and multiply should be on the same level, and add and subtract should be on the same level. We just work from left to right on those. So 10 times 3 add 5. I'm going to do my brackets first. 3 add 5 is 8. And 10 times 8 is 80. Question number 5. Find the number that is exactly halfway between 7 and 15. Now, I think I marked this one. And I remember lots of students just writing out all of the numbers. There is absolutely nothing wrong with that. That works really well as long as there isn't very much in between. Okay, so then 7 and 15, people crossed off either end to find that the middle number is 11. Now, if you wanted a better method, a method that would always work no matter how big the numbers are, you can always add them together and divide by 2. It's a little bit like finding an average. So you could do 7 add 15, and you could half it to find the average. 22 divided by 2 is 11. So either way, we get 11 as our answer for that one. Question number 7. In Adam's garden, the flowers are only red, white, yellow or blue. The chart shows the number of red flowers, the number of white flowers and the number of yellow flowers. The total number of flowers is 30. Work out the number of blue flowers. So we have our frequency going up the side here. We know how many flowers there are by this number here. We've got 8 red, we can see that that is 8 there. We've got 10 that are white, and we've got 5 that are yellow. If we add that together, 10 add 8, add 5, 8 add 5 is 13, carry the 1, 1 add 1 is 2. So I've got 23 flowers so far. The rest of them have to be blue because I've only got those 4 colours. We were told that in the question. So 30, take away 23, and that is 7. Remember, if you've got more on the floor, you need to borrow from next door. 10 take 3 is 7. 2 take 2 is nothing. So there we go. 7 is how many blue flowers we've got. Write down the mode. Now, the mode is the most common. So which colour of flower was the most common? Looking at our graph, I've got 8, I've got 10, I've got 5, and we know that there are 7 blue flowers. The most flowers were white. 10 is our mode. So, well, 10 is the frequency that belongs to the mode. The mode is white. So don't write down 10. The mode is white. The most common colour of flower is white. Question number 9. Ruth left her home at 9 a.m. and walked to the library. She got to the library at 10:30 a.m. Ruth walked at a speed of 4 miles an hour. Work out the distance Ruth walked. So speed, distance, time. If I want the distance, I'm going to take her speed and multiply it by the time. She left her home at 9 and she got to the library at 10:30. So that is an hour and a half. You could write 1.5 or you could write 1.5, that would be fine. And she walked at a speed of 4. So we're going to do 1.5 times 4 miles per hour, or 1.5 times 4. Now, 1 lot of 4 is 4, and half a lot of 4 is 2. So 1.5 lots of 4 is 6. The other way to do that is to do 15 times 4. 4 times 5 is 20. 4 times 1 is 4, add the 2 is 6. But then because I want to do 1.5 times 4 instead of 15 times 4, I need to just divide it by 10, so that would be 6 as your answer. Ruth got to the library at 10:30 a.m. She stayed at the library for 50 minutes. She then walked home. Ruth took an hour and a quarter to get home. At what time did Ruth get home? Now, when we've got these questions talking about time, I like to do a little timeline along the question. So 10:30 was when she got to the library and she stayed there for 50 minutes. Now 30 minutes takes us to 11 o'clock. I always find it easier to go to the next hour. And then it would be another 20 minutes in order to have added 50 altogether. So at 11:20, she's done at the library. She's now going to start walking home. Ruth took an hour and a quarter to walk home. So an hour on from there would be 12:20, and quarter of an hour, 15 minutes, that's going to be 12:35. So 12:35 p.m. in the afternoon. Question number 11, and we've got 74 times 58. Now this is a really common non-calculator question to have to multiply numbers. We don't have a calculator. There are two ways that I would recommend doing this. Now, having marked hundreds and thousands of responses, I have a method I prefer, but I'm going to teach you both, and then I'll let you make your mind up based on what you get on with. So in primary school and for your SATs, you would have been taught column, multiplication, and probably through a lot of school. Now, when we do this, we need to start with the 8. And we're going to do 8 times 4, which is 32. So 2 goes down, carry the 3. And then 8 times the 7, which is 56. 56 add 3 is 59. So we've dealt with that 8. That's all sorted. Now we're going to move over to the 5, except it isn't actually a 5. It's 50. So I need to put a 0 in here. Lots of students put a little smiley face in it to make sure you remember to do it. Now 5 times 4 is 20. So 0 carry the 2. And 5 times 7 is 35. Add the 2 is 37. Adding those together, 5 add 7 is 12, so 2 carry the 1, and 3 add 1 is 4. So 4,292. That's method number 1. Now, if you're not confident on that method, and you're already in year 10, year 11, then I would say that isn't the method for you. If you're really confident and you always do it that way, and you're happy that you get it right that way, then do it. But if you've got to secondary school and you're not feeling confident with that method, then I would say it probably isn't the method for you. And I'd really encourage you. Students that I saw on GCSEs that did this method tended to go wrong less often. Just what I observed. So I'm doing 2 boxes going across because 74 has 2 digits. I'm doing 2 boxes going down because 58 has 2 digits. And I'm going to write 74 across the top times 58 going down. If you had 3 digits, you'd have to just make it 1 box wider or 1 box taller, whichever. Every single box needs to be split diagonally. So you're going to go from the top right corner to the bottom left. Top right to bottom left, top right to bottom left, top right to bottom left. And then just make each of those lines a little bit longer. That is the hardest bit. Now it's fairly plain sailing, I think. 4 times 5. So 4 at the top times 5 at the side. 4 times 5, that is 20. So I'm going to put 20 like that. 4 times 8 is what we're going to do to look at this box here. 4 times 8 is 32. So 32. 7 times 5, so that's going for this box here. 7 times 5 is 35. And 7 times 8 is 56. So that's going in that box down there. All you do now is add down each diagonal section and carry if you need to. So in the first diagonal section, I've just got 2. In the next diagonal section, I've got 6 add 3 add 0, and that's just 9. In the next diagonal section, I've got 2 add 5 add 5, and that's 12. So 2 goes there and we carry the 1. 3 add 1 is 4. 4,292. Now, a lovely thing about that method is if you had decimals, you just go down with one decimal and across with the other, and wherever they meet, you go down that diagonal, and it also tells you where to put the decimal point if it was a decimal, but it wasn't in that case, so we'll just go with our answer of 4,292. Does not matter, which way you do it. Both of those are referenced in the mark scheme as a suitable method. So is the grid method, but I really discourage you from using that one just because it tends to go wrong so often. So 4,292 is your answer, and that's 2 marks. You only need to do it one of those ways, of course. Question number 13. The length of a line is x centimetres. Write down an expression in terms of x for the length of the line in millimetres. Looks really scary because they've put an x in there. If I said I've got a line that's 5 centimetres, what would that be in millimetres? Well, 1 centimetre is 10 millimetres. So to go from centimetres to millimetres, we're timesing by 10. So that would be 50. If I had 3 centimetres, that would be 30 millimetres. So all I'm doing to go from centimetres to millimetres is I'm timesing by 10. So if I've got a line that is X centimetres long, I need to also times it by 10. Now I'm not going to write X times 10. I'm going to write 10x. When we want to times a letter by a number, we just put the number in front. So 10x is your answer for that one. Question number 15. Write down the value of the square root of 64. So this tick symbol is asking you what number times by itself makes 64. Something times something that makes 64. And that would be 8. It has to be the same number on both lines. So the square root of 64 is 8. Write down the value of 5 cubed. Again, these are really common non-calculator questions. They know you haven't got a calculator and they want to test whether you understand what this means. So 5 cubed means 5 times 5 times 5. You're multiplying 5 by itself, which is 25, and then you're timesing that by another 5. And 25 times 5, let's just use our method like this. 5 times 5 is 25, and 5 times 2 is 10, add the 2 is 12. So that is 125. Question number 17. Stuart throws a biased coin 10 times. He gets 7 tails. Maxine throws the same coin 50 times. She gets 30 tails. Prasha is going to throw the coin once. Whose results will give the better estimate for the probability that she will get tails, Stuart's or Maxine's? You must give a reason for your answer. Stuart only threw the coin 10 times, but Maxine threw it 50 times. Therefore, we would trust Maxine's results more because she did it more times. So Maxine, as she did more trials, or you could just say she did it more times, but we like trials in probability. That's a good way of putting it. Part II is to use Stuart's and Maxine results to work out an estimate for the probability that Prasha will get tails. Now we're putting their results together. So Stuart has thrown it 10 times, Maxine has thrown it 50 times. So in total, 10 add 50, they've thrown it 60 times altogether. Stuart got 7 tails and Maxine got 30. So in total, they got 37 tails out of 60. So therefore, we're going to use that probability, 37 out of 60. Question number 19. Work out 2/3 minus 1/5. Now, when we're adding or subtracting fractions, we want to make the denominators the same. I need the first number that's in the 3 times table and in the 5 times table, and that's going to be 15. So we're going to make both of the denominators, the bottom numbers of the fraction, 15. What have I done to the first fraction to make it out of 15? Well, I've had to multiply the bottom by 5, so I also need to multiply the top by 5, and that keeps it equivalent. So 2/3 is the same as 10 out of 15. On the second fraction, I've multiplied the denominator by 3, so I also need to multiply the numerator by 3, and that keeps the fraction the same and makes it 3/15. Now that we've made the denominators the same, we can go ahead and do 10 take away 3, which is 7. So 7/15 is your answer. You don't need to add or subtract the bottoms when you're adding and subtracting fractions. You make them the same and then you keep it out of 15 or whatever it would be. Okay, part B, work out 2/3 times 3/4. Now, when we're multiplying fractions, you do not need to make the denominators the same. This is the nicest thing you can be asked. We're just going to do the numerator times the numerator, top times top, and the denominator times the denominator. So 2 times 3 is 6, and 3 times 4 is 12. However, we've got to write this in its simplest form, and both of those numbers are in the 6 times table. So I'm going to divide the top by 6, divide the bottom by 6, and that is 1/2, 1/2. Lovely, there we go. You might have spotted that they were both in the 3 times table, divided by 3 and got 2/4, and then you could just divide that by 2 to get that. Or you might have halved it and got 3/6. Either way, they're both in the 3 times table, so you still always should have got a half as your final answer. Question number 21. There are 40 students in a class. Each student walks to school or cycles to school or gets the bus. There's no overlap there. They're either getting the bus or they're cycling or they're walking. So they're not doing more than one thing, so we can rule out using a Venn diagram here. There are 22 girls in the class. 9 of the girls walk, 7 of the boys cycle. Okay, so we've also got girls and boys going on. So this is going to be a two-way table. I've got girls and boys and the total. And across the top, I've got walk, I've got cycle, and I've got bus. And again, I'm going to put total on the end. You always want a total for the end of the row and at the bottom as well. There we go. So there's 40 students in the class. We know that it needs to add up to 40 in both directions. There are 22 girls in the class. So the girls is all of these boxes. So at the end, we need to make sure that that says 22. If there are 22 girls, there must be 18 boys, and that's because we know that the girls and the boys need to add up to make 40 as our final answer there. And then we've got 9 girls walking to school, so 9 girls walking. 7 of the boys cycle, so that goes there. And 6 of the 10 students who get the bus to school are boys, so 6 out of 10 are boys, which means 4 of them would be girls. Let's just carry on filling this out. So I know that 9 and 4, that makes 13. So we need another 9 to make that row add up to 22. 9 adds 7, so coming down here, that is 16. And then 7 and 6, that makes 13. So we must be missing 5 more to make that add across to equal 18. And 9 add 5 is 14. Let's just double check because I haven't used these 3 at all. 14 add 16, that's 30. Add 10 does make 40. So I'm happy that we've got this correct. Find the number of students who walk to school. So therefore we just need to look at walk. We've got 9 girls walking, we've got 10 boys walking. So in total, 14 would be our answer for that. 4 marks, lovely. Question number 23. Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar and 2 times as much butter as sugar. Dion is going to make 60 biscuits. Work out the amount of flour she needs. So for 15 biscuits, it says that she needs 50 grams of sugar. It also says that she needs 3 times as much flour as sugar. So if I times that by 3, I get 150 grams of flour and 2 times as much butter as sugar. So I'm going to times by 2, this one, to get 100 grams of butter. But that's for 15 biscuits and she's going to make 60 biscuits. So I need to multiply that recipe by 4. 15 times 4 is 60. So we're going to need to times that recipe by 4. And that's going to be 200 grams of sugar, 600 grams of flour, double it and double it again, and 400 grams of butter. For this part A, the only bit they actually are interested in is the 600 grams of flour. Work out how much flour she needs, so that is 600 grams. For part B, it says Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. How many packs of butter does Dion need to buy? Well, we know, because we've already worked it out, that she needs 400 grams of butter if she's making 60 biscuits. So needs 400 grams of butter. 1 pack is 250. And that's not going to be enough. If I buy another pack, it's going to be 500. And that will be enough for our 400 grams of butter. So therefore, she's going to need 2 packets. Question number 25. The diagram shows the plan, the front elevation and the side elevation of a solid shape drawn on a centimetre grid. So the plan is the view from above. The front elevation is the view from the front and the side elevation is the view from the side. So from above, this shape looks like a circle, but from the front it looks like a rectangle and from the side it looks like a rectangle, and we need to sketch it. So hopefully it makes sense if I tell you guys that this is a cylinder. And to sketch that, don't worry too much about it being super accurate. I'm going to try and do 2 identical circles, or ovals, I guess. Oh, I've not drawn that very well. I'm going to do it again. This is why we always use a pencil, I guess. Like that. Again, it's not great, but hopefully that makes sense. It's a sketch, so you're not going to be marked down as long as you can clearly draw a cylinder of some kind. Give the dimensions, so we can see that going all the way across, that is 4 centimetres, because we can see from this side to this side that it is 4 wide. We can also tell that from above. How tall would this be? Well, we're going from the bottom to the top, and that's 1, 2, 3, 4, 5 centimetres tall. Going up. There we go. Give the dimensions. It was on centimetres, centimetre grid, so we know it's all centimetres for every square. 2 marks for that. Question number 27. A shop sells packs of black pens, red pens and green pens. There are 2 pens in every pack of black pens, 5 pens in every pack of red pens and 6 pens in each pack of green pens. On Monday, the number of black pens sold to the number of packs of black pens to the number of packs of red pens to the number of packs of green pens was 7 to 3 to 4. But that's packets. Now, we know if 7 to 3 to 4 is black to red to green, each packet sold of black pens only has 2 pens in it. So I need to times this one by 2. Each red packet that was sold has 5 in it, and each green packet that was sold has 6 in it. So I'm going to put 14 to 15 to 24. That's now going to be the ratio of the number of pens. It says a total of 212 pens were sold. So what does this add up to at the minute? 14 add 15 is 29, and 29 add 24 is going to be 53. So if I double that ratio, 28 to 30 to 48, it's now going to add up to 106 parts. We want it to add up to 212, so I'm going to double it again. You could do 212 divided by 53, which is 4, times each number by 4, but I think it's easier to work up here. So this is 56, that's 14 times 4. 15 times 4, or 30 doubled, is going to be 60. And 24 times 4, or 48 doubled, is going to be 96. So these are how many of each colour pen was sold. Work out the number of green pens sold. Green is the last number in the ratio, so that's going to be 96 green pens. Great. I'll put 96 on the outside, shall I? Question number 29, I think this is the last one on the paper. We've got a quadratic graph. I know it's a quadratic because of the shape of it. It goes down and comes back up. It might be that way up, but this one is positive, so we've got that smiley face shape. Here is the graph of y equals x squared minus 2x minus 3. And it says, what's the coordinate of the turning point? Now, don't overthink it. This is a lovely, lovely question. What is the coordinate of the point where it turns? That is this point here. That is the turning point. What's the coordinate of that point? So many students get these the wrong way around. Remember, you're going along the corridor up the stairs. So this is 1 minus 4. We're going across to 1 and down to minus 4. Use the graph to find the roots of the equation x squared minus 2x minus 3 equals 0. So the roots are where your quadratic crosses the x-axis. So if you're asked when does it equal 0, we're looking at this value here and we're looking at this value here, and that is minus 1 and 3. Looks like a really scary question, but you're just identifying the key points. Minus 1 and 3 are the roots. They're the x values where that equation would equal 0, and the turning point 1 minus 4. Hopefully you found that helpful. If you've got any questions, let me know in the comments, and I will see you guys next week.